circled that. So what we're going to do here is we're solving our radical equations, bless you, is once it's isolated, number one is, now I forget, if I don't see a root here, what's my root? 2. So since that's 2, that's the power that I need to take both sides to, because those are inverses, and just leave me with what's left underneath it. 5 squared, though, is 25. So the right side of your equation will have some changes. And unlike your power equations, you're not going to have 2 solutions. We're just going to subtract the 3 and then divide by 2. And then again, just double check real quick to make sure it works okay. If I plug 11 back in, 2 times 11 is 22, plus 3 is 25, the square root of 25 is 5. Okay, that one's good. And for any of these that I do, again, this is the same thing as having a 5th root. I'm just seeing it in a different way. I'm still going to use that denominator, or that root number, as the number I take both sides to when I exponentiate. The 5 and the 1/5 will cancel, just like as though it were a 5th root. I'm left with what's in the parentheses. 3 to the 5th power is 243. And again, it's not multiplying, it's an exponent that you're taking it to. I'm going to add my 1 over and divide by 4. And then make sure I'm right. You're like, well, let's see. 61 times 4 is 244, minus 1 is 243 to the 1/5. May not know that one off the top of my head yet, but there's a couple of ways I can double check here. One of them is, if I've got my chart out here still, I'm like, let's see here. So 61 was 243, and I'm looking at the fifths. There's my fifths. And 241, 243 to the 1/5 should be 3, and it is. Okay. Again, if I don't have my chart, if I've misplaced it, if I don't have it, handy, I always can double check. Once I plug that in and see that it's 243, I always can punch it in on the calculator, and I see it's 3, and I'm good that way too. So either one of those would work as far as that goes. But then when we get to the next one, we run into our first issue. That has to be isolated before I do my exponentiating. I've got to minus the 3. And once that's isolated, now I can go back in and use my 3 exponent to take care of those. And again, it just leaves me with what's underneath the radical. And I can get my solution. And I'm like, okay, 2 times 4 is 8. Cube root of 8 is 2. 2 plus 3 is 5. Okay. Still feeling good about this. Nothing going too bad so far. So let's see. This is another interesting issue. 2 radicals in the same side. Never can have more than 1 radical on a side, or at least we try to avoid that. So I'm going to add this to the other side. And it's actually going to make this one of the easier problems that we deal with. Because once I have 1 radical per side, and it's a square root, I can square both sides. My inverses of square root and squared take care of each other, and I'm just left with what's underneath. Add my 4 over and divide by 5. Now sometimes we may not get quite so lucky. There may be only so much we can do to get a radical by itself. Here, you're like, well, I want to get that 2 out of there, but wait a minute, if I do it, it's going to be over here, and that's still on a radical side. That's okay. If that happens, I still can go ahead and square both sides, but here's the kicker. On the right side, it's just left what's underneath. Over here, that 2 goes to both the 2 and to the radical. So 2 squared is 4, but then the squared and the square root part just cancel. So I'm going to have a little bit of distributing to do. And the biggest thing with these is people forget about the 2. They just leave it as 2. It's like, nope, got to deal with that as well. And as long as I remember that, and now I just solve the equations left. I minus my x over, subtract my 44, divide by 3. So I look at this for a minute and I go, okay, so I've got to plug this in. Negative 14 plus 11. Wait a minute. Negative 14 plus 11 is negative 3. I double checked this for a minute. I'm like, wait, square root of negative 3. Uh-oh. Okay. I've got non-real answers. When I get non-real answers, that's not something we're going to work with. So this one, my answer doesn't work, and since it's my only answer, I don't have a solution to this one. So that's what I mean when I talk about checking your solution quick. Because you did all the right math work all the way through, but the solution really isn't one. So be careful. Be careful, be careful, be careful. So between that and making sure I isolate my term here. Now here, I'm actually going to add the radical to the other side because I don't want to deal with the negative. That's an option I have. So what exponent am I going to be taking both sides to? To 4, yeah. Because it's always about taking care of that root. And 5 to the 4th is 625. And again, if I'm not sure, I can go to the chart that I have. Or if I don't have the chart handy, let's double check. So I'd have 5 minus 625 to the 1/4. Bingo. Okay, that one works. So as you see here, and this is about accurate to how often you're going to find one that's no solution. It's not often. Just to make sure, okay, when you're doing those answers, because it's kind of scary when you can do all the right math work and still have something go wrong here. So let's see if we can run ourselves into any other dilemmas here. Okay, what happens? Still got to isolate my x. So I'm going to divide by 3. You're like, here's a new one. What in the heck do I do now? It's not just a single thing. It's like 4/3. Well, I want to turn it into x, right? Which would be x to the first. So if I'm multiplying, I'm going to take both sides to the reciprocal power. So what I'm going to do here is I'm going to take it to the 3/4 power. And this is where having my calculator can come in handy if I don't want to play around here too much. 1 to the 3. And I can get my answer that way. And now, if you do go to plug it into the calculator to check, notice how before when we did the story problem, we wanted to do things in pieces. We're going to do things in pieces again. I'm going to do the 27 to the 4/3 first, and then multiply it by the 3. And whoops. Harty. And I get my 243. That works. So those are the types of things that we're trying to do with this. So let's see. Isolate my radical minus the 6/. Now here again is something I got to watch out for. If that were a square root, I wouldn't be able to do this because I got a negative over here. But a cubed root I can, because cubed roots can be positive or negative. Negative 5 cubed is negative 125. And then I go, oh, well, I kind of just figured that out. The cubed root of negative 125 would be negative 5 plus 6 is 1. Okay, not too bad. Let's see here. Let's try out number 10 just to make sure we're doing okay with this stuff. Whenever we're trying to isolate a variable, work from the furthest away in. So don't try to dump the fraction right away because this will end up being a pain in your butt. So I'm going to add the 4 over first. Now I can dump the fractional part. Now I can multiply by its reciprocal to take care of this. Again, 10 times 2 is 20. Divided by 5 gets me to 4. And now it looks pretty normal. So I'll just square it to both sides. Remember, 4 squared is 16. Minus my 8 over. Divide by 2. And let's see, let's make sure we're right here. So if I plug in my 4, that'd be 8 plus 8 is 16. Square root of 16 is 4. 5 times 4 would be 20. Divided by 2 is 10. Minus 4 is 6. Okay. But that's how I'm going to work these. Okay. Isolate my exponent or my variable term. Then use my exponentiation either as a reciprocal or just using that same exponent to cancel out my root and to get the answer. So like we mentioned on the other side when we were at number, I think it was number 6. Yes. Number 6 would be an example of what's called an extraneous solution. And that basically is, I did the math right, but the answer is not true. So it happens when you get no solution. Okay, it's kind of the same type of idea. Get an answer, but it's kind of a fake. And again, some of the other things we're going to start doing is kind of talking steps out to kind of start thinking that way a little bit more. Because you guys basically are going to be the ones that get to be the guinea pigs next year when we start this new testing out. Because the juniors next year get to start the new federal testing thing that goes on, and we got to see some of the questions this morning, and I was like, so we're going to start explaining things a little bit more to get you guys ready. More information coming on that as I get it. So Marcy began solving x to the 2/3 equals 5 by cubing each side. What would her next step be, or what could she have done to solve the equation in just one step? Well, let's think about what she did. Here's her problem. And she decided she was going to cube each side first. Now, that would cancel, but she'd still have the x squared part. So what would she have to do next? Yeah, so we'd have to square root both sides if she did it her way. Well, what could she have done to take care of it all at once? Yeah, she could have taken both sides of the equation by the reciprocal, or the 3/2 exponent, but I like your wording better. We'll call that the reciprocal. That will get great scores on the testing for next year if you fire off with reciprocal exponent. But that's the type thing we're going to start having you do a little bit more to try and help out with that. And then in words, what would I do for number 15 to get that rolling? Yep. We're going to add square root of 7x minus 4 to both sides. And we'll even add in to isolate our radicals. So a lot of you think this stuff already, you just don't put it down on paper real often. And so this is just kind of trying to help you think through that a little more. Okay, so here's a couple things to keep in mind. This is going to be our third assignment in homework check 5. This homework check won't end up due until next week. So you've got a little flexibility here. Tomorrow, post-quiz, we're just going to keep working on this same stuff. I've got a short worksheet that kind of reinforces this. So you'll have some time to work on this too. But for the time being, what I want to do is take on any questions that you've come up with as you're messing with the quiz preview. Now again, I've got a key up here, which you are absolutely free to peek at if you're looking for a little more in-depth than just the answers. I'm tempted to even post this online tonight, but we'll see. But if there's questions that you're like, okay, I tried something and my answer looks nothing like what you have over there, what the heck is going on? This is a good time to let me in on that so I can try to make this next quiz score look good, because I believe this will end up, yeah, we've got all, I haven't even mentioned the other partial thing yet, but I'll get to that in a minute. So any questions so far? Yes, ma'am. Number 3. Okay. Our first rule every time when we're doing anything with factoring is the golden rule, which is, do we have anything in common? So I look at 20x squared and I look at 4x and I say, okay, as far as the coefficients go, I can go ahead and get a 4 out of each of those. But I also have to keep in mind both terms have x's. So to figure out how much I can take out, I always just take the one with the smaller exponent. So I've got 4x out of there. So then I got to see, okay, well, what have I got left over? I don't know. I might be able to factor what's left still. So 4 times what gets me to 20 is 5. X times what gets me to x squared is x. And then I got to remember, even though I see these both say 4x, I got to hold the place still. So to get from 4x to negative 4x, I'd have to multiply by a negative 1, and then I can't factor anything that's left in there because I don't have a squared term left. So that's as far as I can take that one. Sometimes they will come up a little bit short on that side. Any others immediately come into mind? Because again, you know how I work with the quizzes. The previews will look just like the quiz. I'm just moving numbers around. So are there any others right away that you're seeing that are troublesome? Because while some of you are looking and kind of checking things over a bit, I'm going to make mention of one other thing. And I sent an email out this morning to parents about this too, especially with how tests work in here. So let me give you the heads up on the other sheet you picked up. Okay. That Unit 1 test review Part 1. Notice it says Part 1. There's going to be a second part that's coming. This test is going to be next Wednesday. As soon as you walk in next Wednesday, they'll be on your desks. You can sit down and start on it. It absolutely can be done in a class period, but you need to be ready and you need to pace yourself somewhat. Remember the rule with the tests, though. Tests cannot be retaken. So, you really want to make sure you're ready for this. And again, you know how I work. The review is going to look just like the test. Same size, same types of questions, same order, same everything. So you'll have both of these in your hand going into the weekend. Monday and Tuesday, all we're doing on Monday and Tuesday is working on it, asking questions, and going back over things, making sure you're ready. because then Wednesday we get it, and we get after it, and we kind of see what's up. So just something to keep pondering. Your focus now, of course, wants to be the quiz because, well, that's sooner. But it's something to start considering so you don't get yourself last minute trying to scramble, because it's kind of important when we only get a few of these in a semester that you do well. Okay, enough of the lecture. Any more questions so far on the quiz preview? Anybody's going to be watching online later is going to be like, oh my gosh.